Our next topic is building Aneka Clouds. Aneka is primarily a platform for developing distributed applications over the cloud. That is, it is another software platform that requires infrastructure, as we know, infrastructure as service, which provides hardware to be deployed on the cloud. So this infrastructure needs to be now managed by any interface. That we'll see here. Infrastructure management tools that are specifically designed for doing this task of managing the infrastructure that is deployed on the cloud. As we are aware that the cloud can be deployed in three ways: public, private, and hybrid modes. So these Aneka platform can also be managed in these three types of modes. Now, first thing is to be organized is infrastructure. So that is we call it as infrastructure organization. Here you can see the diagram of the infrastructure organization. So all the devices are connected to the internet, wherein we have several types of devices. We'll see one by one. First one is the Aneka repository. This is where exactly the actual data is being stored. Now it can be accessed through these HTTP or file share like FTP or any other applications to upload or download data onto the Aneka repository. Now we have several other devices it may be a desktop PC or it may be a public cloud infrastructure, whatever it is, will have two major elements. One is the Aneka container and the node manager. So the node manager controls the operations that are being executed on the infrastructure. So each and every PC or each and every cluster will have a node manager. So on each and every individual system, we again have Aneka container, which is the actual execution unit of the program. Here we have the n number of PCs or clusters wherein each and everything has a node manager and Aneka container. So, and we have one more thing called as management console. So, that management console controls the operation. So, all the desktop PCs or cluster PCs or public cloud that has been deployed under Aneka Cloud. So, it manages the user access, where the data to be stored, which container has to be provisioned with what kind of resources. So that is the total task of management console. So this is how infrastructure can be organized in Aneka Cloud platform. Okay, so here we use several protocols like HTTP, FTP, and common filing sharing protocols for uploading or downloading the data onto the Aneka repository. The management console plays a crucial role in handling multiple repositories, enabling the selection of most suitable one for a specific application deployment. Okay. From an infrastructure perspective, the management of both physical and virtual nodes is executed uniformly, assuming that there is an internet connection and remote administrative access to each and every node that has been deployed onto the Aneka platform. Now, next thing is logical organization. How logically all the nodes in the cluster are connected. Here we see there is a master node which has 7 features, that is named as index master, scheduling, accounting, reporting, reservation, provisioning, and mandatory column. So all these perform a different role on the master node. So for that master node, we have several other nodes called as storage node and worker nodes. So for actual data storage, we use the storage node. So there are n number of storage nodes based on our infrastructure organization. And we have another backup copy of master node, that is whenever a failure occurs in the master node, immediately we'll have another backup server which acts as a master node, which keeps replicating periodically to maintain the redundancy copy of the master node. So if any time the master node is failed, immediately the failover copy will be up and running, serving the other storage nodes and worker nodes. So the storage nodes have three elements, which is index, slave version, storage, the actual storage data, and the mandatory specifications that are need to be maintained. So again, we have a number of storage nodes to maintain redundancy of the actual data. And the next thing is worker node. So we have a number of worker nodes based on our application deployment. Each and every work node will have index, execution element, that is a container, and the allocation of resources and the mandatory elements that need to be taken care while executing the application. So all these worker nodes will share the workload of the actual application, how we allocate them to perform. So this is how logically all the master node, storage node, and worker nodes are connected in the application of cloud. So it has highly diverse, primarily influenced by the configuration chosen for each container. So there is a container which actually executes the application. One common scenario here involves a master worker configuration with a dedicated nodes for storage. As we have seen in the diagram, this is how all these master worker and storage nodes are connected to each other. Now, the role of the master. In this infrastructure organization of Aneka Cloud platform, the master node plays a pivotal role which houses the services that are often present in a single instance. That is, for every single instance, whatever the services need to be hosted will be taken care by the master node. It serves as the intelligence hub of the Aneka Cloud, a key characteristic that defines a node as a master node in the presence of index service, typically configured in master mode. Other services, except for mandatory ones, may be distributed across different nodes. So the workload of a master node can be easily distributed among several nodes. A standard configuration for the master node includes services such as heartbeat. Heartbeat means here whether the service is running or not, checking periodically. Next, logging. So recording all the transactions being carried out on the server node. And then reservation, how a reservation of resources can be done. And resource provisioning. So if the resources are exceeded the limit, then we can add additional resources. And then accounting, reporting and monitoring and scheduling the resources. So this is the main role of the master node in the logical organization. Next, its features. So the master node is responsible primarily for connecting RDBMS, that is a relation database management system, where it maintains the state of several services. So it keeps maintaining the services that are being run on the servers, that is in the master node. Scheduling services are also hosted on the master node itself. That is, these services share the application store, typically purchased on the RDBMS, to ensure fault tolerance. This master configuration can be replicated across multiple nodes to establish a highly available infrastructure using failover mechanism. So that is, by maintaining the replicated copy across multiple nodes, whenever a problem occurs to the master node, then the using the high availability concept, we can maintain another backup copy. Okay, so that is the master node feature. Now we'll see worker nodes in the Aneka clouds. Here, worker nodes forms as the workforce of Aneka clouds and are primarily configured for executing the applications. So that is the actual execution of application will be carried out on the worker nodes itself. So they include mandatory services and the specific execution services for each supported programming model within the cloud. So it will take care of the actual execution of the application on the cloud. A typical configuration for worker nodes comprises like index, heartbeat, logging, allocation, monitoring, and execution services tailored to the cloud's supported programming models. Now, first type of deployment, that is private cloud deployment. So here we see how a Aneka can be deployed in a private cloud. So here we'll have the physical infrastructure can be maintained in the form of clustered workstations or clusters of pieces or normal desktop machines can be maintained to provide infrastructure services to the Aneka. So on the master node, we have several services such as application management and scheduling, which is a primary important role, and then resource provisioning, so resources supplying to the application, and then resource reservation, what size of resources needed at what point of time. And then we have another equilibrium systems, that is, if the resource provisioning will keep on monitoring these systems, and whenever there is a exceed in the load, then automatically it assigns additional resources by resource provisioning feature. They may be called as they may be formed in the way called as virtual clusters. Okay. This is how a private cloud can be deployed. A private deployment mode primarily consists of local physical resources or infrastructure management software that grants access to a local pool of nodes which may be virtualized. So that is a local physical available resources can be formed in a form of pool, and they will be virtualized using any virtual machine software. In this context, Aneka clouds are established by harnessing a diverse pool of resources, including desktop machines, clusters, and workstations. These resources can be organized into distinct groups, and Aneka can be configured to utilize them based on the specific needs of applications. Furthermore, with the aid of the resource provisioning service, it's possible to integrate virtual nodes provisioned from a local resource pool managed by systems such as Zen Server, Eucalyptus, and OpenStack. So these type of services can be used to provision additional resources when we are in high demand of resources. So as in the figure, we see a typical deployment for a private Aneka cloud. This deployment is suitable for scenarios in which the system's workload is predictable and a local virtual machine manager can easily address any excess capacity demands. Most Aneka nodes consist of physical nodes with long lifetimes and static configurations which typically do not require frequent reconfiguration. That is, once they are configured, they'll work up to the lifetime of the machine. The distinct nature of the machines employed in a private environment enables the implementation of specific policies for resource management and usage, which can be achieved through the reservation service to reserve the resources that are needed for future. For instance, desktop machines used during the day for office tasks can be leveraged outside standard working hours to execute distributed applications, while workstation clusters may be designated for running applications with special requirements given their specific legacy software support. Now we'll see public deployment mode. So, as we have seen in private cloud deployment, there we have used local physical resources to provide services to the cloud. But whereas in public cloud deployment mode, we'll have public servers hosted on several cloud service providers such as Amazon, Google, or some other service providers. See, in this diagram, we have master node and slave nodes. The slave nodes are being installed on Amazon EC2 instance, that's Amazon Cloud, and there are several Amazon EC2 instances which will be running to maintain the master node also. Here the master node takes care of application management and scheduling, reporting, billing, accounting, resource provisioning. So these control the allocation of resources that are available on the physical node on the Amazon EC2 instance. Here, the slave nodes will be installed on the Amazon EC2 instances, and they actually carry out the execution of the application. Here, the cloud deployment mode involves setting up Aneka master and worker nodes on a fully virtualized infrastructure hosted on the resources of one or more service providers such as Amazon EC2 or GoGrid or any other cloud service providers. In this scenario, there exist two types of deployments. One is a static deployment, where nodes are pre-provisioned and used as if they were physical machines replicating a traditional Aneka installation without dynamic provisioning capabilities. And the second type of deployment mode is Aneka dynamic deployment. It leverages the elasticity features offered by infrastructure as a service providers to create a highly dynamic cloud. The figure provides an overview of this dynamic deployment that we have seen earlier. Typically, this deployment remains within the infrastructure confines of a single IaaS provider to minimize data transfer costs, which are generally higher when transferring data between different providers and to ensure better network performance. That is, we can use several cloud service providers to store data, but when we have to use the application on that data, we will incur several network costs. That is, to transfer data from one cloud service provider to another cloud service provider, we have to incur the cost of the network usage. That is the network bandwidth also used as a service, so they'll charge us. Within this context, it's feasible to establish an Aneka Cloud with just a single node and fully exploit dynamic provisioning to seamlessly scale the infrastructure on demand. So the resource provisioning service plays a fundamental role in this public cloud setup, allowing configuration with various images and templates for instantiation. Additionally, critical services to be included in the master node are the accounting and reporting services, which takes care of the actual billing system. The next one is hybrid cloud deployment. So, as you know, hybrid is a combination of both the public and the private cloud deployments. We'll see how a hybrid cloud is deployed here. So, first of all, the private cloud deployment, which uses local infrastructure, which maintains the desktops and workstations, or clusters or virtual cluster resources. That is like Eucalypt systems or Genix or VMware. Like that, we can use physical systems as a private. And the master node will take care of the application management scheduling, resource reservation, reporting, billing and accounting, and hardware provisioning service. So whenever the local physical resources are exhausted, then automatically provision services will go for the public clouds where a new host of machines can be deployed to use the applications. That is like public clouds, which are like Amazon Web Services, Google Grid, or any other cloud service providers. This is how hybrid cloud deployment is used. The hybrid deployment model represents the most prevalent Aneka deployment approach. In many instances, there is an existing computing infrastructure that can be utilized to meet the computational requirements of applications. This infrastructure serves as the static deployment of Aneka, which can be flexibly and dynamically expanded as needed when additional resources are required. So, this scenario constitutes the most comprehensive Aneka deployment capable of harnessing the full range of framework capabilities, including dynamic resource provisioning, so resources can be provisioned whenever needed dynamically, and resource reservation. So resources can be reserved uh, for the duration we require. And then workload partitioning. So that is we can partition our workload to different servers available. And then accounting, monitoring and reporting. So it accounts what are the amount of resources used. It keeps monitoring whether the resources are working or not. And then reporting to if any error occurs, it will report to the administrator. So in this scenario, diverse resources can be employed for various purposes. That is, we can use several types of systems, desktop systems, or public cloud deployed as a servers can be used. As we mentioned in the context of a private cloud deployment, desktop machines can be earmarked for low priority workloads during non-standard working hours. The majority of applications will run on workstations and clusters, which are the nodes that maintain a constant connection on the Aneka cloud. Any extra computing capacity requirements can be primarily met using local virtualization facilities. If they exceed, then the computing power is needed. External license providers can be linked to use the additional resources. Next one, cloud programming and management. So this is how we manage uh, usage of programs that are deploying programs or deployment of programs on cloud. We'll see this. Aneka SDK. So Aneka is software development kit. It offers several APIs that are used to creation of applications on top of existing programming models, the implementation of novel programming models, and the development of new services to seamlessly integrate into the Aneka Cloud. Application deployment primarily revolves around leveraging existing features and making the most of middleware services. Simultaneously, the implementation of fresh programming models and services enriches the capabilities of Aneka platform. This SDK provides comprehensive support for both programming models and services through two key components called as application model and service model. First, we'll see the application model. Aneka offers robust support for distributed execution in the cloud, abstracting the programming models. A programming model defines both the abstraction employed by developers and the runtime support for executing programs on the Aneka platform. This model represents the essential set of APIs shared across all programming models for the representation of programming of distributed applications on Aneka Cloud platform. An overview of the components that constitute the Aneka application model. Each distributed application running on Aneka platform is an instance of the application-based class denoted as EM, which identifies the particular type of application manager responsible for overseeing the application's execution. We'll see a small diagram here, which has several folder structure, how the application is being managed using Aneka software development kit. The most common category in this model is the task model, thread model, and parameter sweep model. Applications falling within this category are typically composed of a collection of work units submitted by the user, each represented by the work unit class. Each work unit can compass input and output files with the seamless management of file transfers handled during the runtime process. The specific type of work unit class employed to represent these work units depends on the chosen programming model. For example, Aneka task for the task model and Aneka thread for the thread model. So for task model systems, we use Aneka task, and for thread model, we use Aneka thread. All applications within the category inherit from or are instances of the Aneka application class denoted as W, N. Here, W represents the specific type of work unit class utilized, and M indicates the type of application manager employed in the iManual application manager interface. Next one is service. The service model establishes the fundamental criteria for creating a service that can be accommodated within an Aneka cloud. The container defines the runtime environment in which these services are hosted. To be hosted within a container, each service must adhere to the iService interface, which provides access to the following methods and properties. So that is, iService interface will provide access to the following methods to each and every container. So first one is name and status. Second is control operations, including start, stop, pause, and continue methods. Message handling facilitated by the handle message method. We'll see it pictorially. See, here the first stage is initialized. So whenever the service is initialized, it will be in initialization mode. And when we run the iService.start function, it enters into starting phase. Once after the starting phase, the application will come into running mode, where we have several options. If you want to pause the service for any resource requirement or any issues, then iService.pause function is executed, and the running phase will enter into pausing state, and after maintaining the buffer, it will again enter into paused state. After after availing the resources, we want to continue, will enter the function called as iService.continue, which keeps the paused state into resuming, and then the application starts its running phase. Now, once the application completes its execution or deployment, whatever it is, then it executes the function called as iService.stop. And now it enters into stopping state, where it maintains all the buffer, it releases the resources, and then finally it enters to stopper state. So this is the service model life cycle. See, the diagram distinguishes transient states with the shaded balloons and steady states with the white balloons. So transient states means like we are moving into pausing state and resuming state and then stopping state. These are transient states. A service instance can initially exist in the unknown or instance state, signifying its creation when the construction is invoked during container configuration. Once the container is started, it sequentially invokes the start method on each service instance. After invoking that start method, it enters into running mode. Consequently, the service instance is expected to transition into a starting state which will persist until the startup process is completed, after which it enters the running state. The running state is where the service operates as long as the container is active and running. This is the only state in which the service can process messages. In the event of an exception during startup, the service is expected to revert to the unknown state, indicating an error. When a service is in the running state, it has the ability to pause its activity through the pause method and resume it with the continue method. As depicted in the diagram, the service transition initially to the pausing state leading to the pausing state. From this pausing state, it proceeds to the resuming state while restoring its activities and returns back to the running state. It's important to note that not all services need to support the pause state during the operations, and the current framework implementation does not include any services with these capabilities. So this class serves as the fundamental component for numerous services within the framework, offering a range of built-in features like implementation of the fundamental properties exposed by iService, implementation of control operations with integrated login capabilities and state control, inherent infrastructure for delivering a specific service specific client, and then last one is support for service monitoring. Next, last one is management tools. So Aneka is a pure platform as a service implementation model, and it requires virtual or physical hardware to be deployed. Hence, infrastructure management together with facilities for installing logical clouds on such infrastructure is a fundamental feature of Aneka's management layer. This layer also includes capability for managing services and applications running in the Aneka Cloud. Now, infrastructure management. Aneka utilizes a combination of virtual and physical hardware to deploy Aneka clouds. So that is, it uses a local physical available hardware and also virtual hardware to deploy on Aneka clouds. Virtual hardware is typically overseen by the resource provisioning service, which acquires resources as and needed based on the application's requirements. So that is, if there is a high demand, the resource provisioning service will acquire the resources from other sources. Physical hardware, on the other hand, is directly managed through the administrative console, leveraging the Aneka Management API of the physical abstraction layer or platform abstraction layer. The management functionalities primarily focus on provisioning physical hardware and remotely installing Aneka on all those procured physical hardware. Next is platform management. Infrastructure management forms the foundation layer upon which Aneka clouds are established. That is, where exactly the Aneka cloud established will be maintained by the infrastructure management. The process of creating clouds is coordinated by deploying a collection of services on the physical infrastructure, enabling the installation and management of containers. These interconnected containers collectively define the platform where applications are actually being executed. So the available features for platform management predominantly revolve around the logical organization and the structure of Aneka clouds. There is a logical organization which I have seen earlier is used here for platform management. It is feasible to partition the existing hardware into multiple clouds, each configured differently for various purposes. That is, the available hardware can be partitioned into several multiple clouds, where you can configure each of them individually. Services implement the core features of Aneka Clouds, and the management layer provides operations for some of these core features, including cloud monitoring, resource provisioning, reservation, user management, and application profiling. Next one is application management. Applications represent the user's contribution to the cloud. The management APIs offer administrators monitoring and profiling features that assist in monitoring resource usage and associating it with users and applications. This is a critical feature in a cloud computing environment where users are billed based on the resource consumption, that is the pay-as-you-go model. Aneka provides capabilities to offer both summary and detailed information about application execution and resource utilization. All of these features are easily accessible through the Aneka Cloud Management Studio, which serves as the primary administrative console for the cloud.